Welcome back, everybody. I just want to make a updated video on some of the changes I made to my bug bounty automation framework. It's very similar to the old one, but also in some ways a little bit different. It's a work in progress, obviously, still, and I want to talk about some of the things I've changed, why I changed them, and then some things I might also change in the future as it scales. So I'm going to try and keep it as short as possible, maybe a little bit longer than some normal ones. I may be right on time, I'm not sure. We'll see how it works out here. But I have a little diagram that I think people have seen before, and it might have changed a little bit, but basically some of the things that I'm aiming for right now with the automation. I'm going to talk about what it used to look like, what it looks like now, and why I changed it, and then as well as how I may continue to scale it or change the architecture in the future. So let's get right into it. So to begin here, this chart I think I showed in one of my other videos. It looks pretty much very similar. Maybe a thing or two have changed, but this is like just basic how it works. Again, the stuff in red that shows up is, and I know the like color scheme is terrible here. It was a super quick thing. I didn't know it was a black background. Okay, sue me. The words look readable to me, so that's what really counts. But the red stuff is stuff that I will apply later. So the red stuff, like you see over here for subzone, MS, and all those takeover checks, will probably actually break out into other workers, not their own thing. So that's the red stuff is like stuff that will be up and coming. But let's zoom in and go up here to the top. So everything starts with a seed domain. This formula right now is just messing with domains. There's going to be a separate workflow for onboarding IPs and then, doing reverse DNS and that kind of stuff and getting domains related to IPs. And down the road, what I want to try and do, also shout out to Rhino Raider for looking at this for me and giving me some feedback. Some of the feedback he gave, and I think one of the biggest parts to me that made the most sense is mapping domains to IP addresses. I've never really talked about this on any of these streams, but it is something that I'm going to try and do. I'm going to try and do efficiently. And just some of the stuff he talked about and the way he talked about it with IPs and stuff actually made it seem like way more important than I originally thought it was. So there is probably going to be a video on that gets thrown in here at some point. But for now, shout out to him for auditing it and looking over it and giving me some cool tips. So that's really cool. But so you start with the seed domain right now. You have your passive recon, just using a bunch of tools, basically. Look at it that way. CertSH, Subfinder, Mass, Find Domain, Google Dorking, GitHub checking, all that kind of stuff, right? The list is humongous. I didn't put them all in there. And then active recon. Active is just your normal brute forcing, multi-level brute forcing, all that type of stuff, right? And those go into a table called all subs. Again, I've talked about this in some of my past videos, so I'm going to try and fly through this stuff. All subs gets pulled into a permutation thing. I use Regulator by Crampit. I really like it. It runs really fast and it's very efficient for the runtime as far as finding permutations. I know there's a lot of tools out there. It's just the one that I decided to use, so check it out if you would like to. So those permutations also get put into all subs, and then also, since you have to resolve them just to see if they're even a domain for permutations, they'll also automatically get put in the resolve subs table as well. Any subdomains here that came from, obviously, again, when you look at active, anything that I brute force, you have to then resolve. So if it resolves, it can go in all subs and it can go in resolve subs here. But this passive recon stuff, I don't know if it actually is still up or existing yet. So it just goes in all subs. And then those get pushed into the resolver worker that use DNSX from Project Discovery. Again, I'm a fanboy for Project Discovery tools, so there's a lot of those, and they all have Golang libraries for the most part now, so that works out pretty well for me because all my automation is written in Go. So it all goes through there, it resolves, it goes into the resolve subs table. Again, in the future, that's probably what some of these takeovers will grab from. Again, in the future, I might dive more into this step and how I'm like mapping domains to IPs and stuff like that. So if you have, virtual hosts and things like that. But for now, it ends up there. Resolve subs get pushed to HTTP probing, which get put in an HTTP subs thing. Again, there will be port scanning over here and a bunch of this stuff. This is just really, really basic. I have a port scanning worker and stuff like that, but that's all kind of separate. Go through HTTP probing, it goes into HTTP subs, and then there's all this type of stuff you can, do against. You can do fuzzing, which you can also do with nuclei now, but there's nuclei, jails, fuzzing, parameter testing, behavior analysis, screenshotting, all that kind of stuff, right? So again, it's in red because that whole red triangle could blow up into something totally, like 80 other workers, right? So this is what just like the recon workflow basically right now. So before, what I was doing was there was one server, a mega server that I had on DigitalOcean, and everything that's a triangle here, not counting the red ones, all the black triangles we'll just say as a worker, right? And that's code that was containerized into a Docker image and then deployed as a Docker container. So I could, on a bigger server that had the computing power, I could deploy all of these as containers. And with containers, when you're deploying them with, like a Docker Compose file or whatever, I could deploy as many containers and auto scale them as I needed. So that was my way of scaling all of these workers. Was if I, for some reason, needed 3 of these and only 1 of these, or probably vice versa, 3 of these and 1 of these, that's great. I could have 1 container of this and 3 containers of that all pulled from a Redis queue that I used at the time and then fed information into a database. That's how it used to be. So it was one server with a bunch of containers sitting on it that scaled up and down, which worked all right for testing, but still scaled semi-poorly. So what I decided to do, also to preamble it, the big problem was I was manually spinning up and spinning down containers. And even in the beginning, like you can set containers to auto scale, and that's great. So they will kind of auto scale on their own with Docker, but it's kind of touchy. And the other thing is every time I had to redeploy code, I had to take down containers, re-put containers, and start it all over and re-Docker compose it and all that stuff. So it got kind of a lot as it got bigger to handle. So what I'm doing now is I can pull it up here. So this is Google Cloud, and this is, for instance, just the container registry on Google Cloud. So I have, some of my workers here, they're not all deployed because, again, there's technically a little cost that comes with that, but I have a few of them deployed that I'm currently working on and currently testing and spinning together. So I can deploy these containers into the GCR, which is Google's container registry. And then from there, I can use, Google has a service called PubSub, which is exactly what it sounds like. It's a PubSub service where you can have anything, a function, a server, you can hit it on an HTTP API, whatever it is, push or publish a message to the PubSub service, and then you can have workers of any kind subscribe to that service. So when something is published, they can receive it and handle it or do the work or whatever. So so that takes the place of the Redis queue. In some of my earlier videos, I don't use Redis queue anymore to queue up my jobs. Instead, I have a PubSub service for every worker that you can publish a message to. So for instance, this HTTPX worker will have an HTTPX PubSub service, and other workers can publish domains to that PubSub service. Say like, okay, I want you to test api.example.com, and it will publish that domain to that PubSub service. Any HTTP workers that are deployed will be subscribed to that, see it, and one will handle it and do the HTTPX stuff and push the results to the database. So I got to cut the cost of the Redis server. PubSub is much, much cheaper. It has a free tier and all that good stuff. So now the question might be, am I still using a mega server on Google, or how am I doing this? And the answer is no. What I'm actually doing is I'm splitting all of this work into such minimal pieces that it can be done very quickly. So for instance, when I'm resolving domains, I don't hand my resolver worker my 30,000 domains that I just found from my Yahoo subdomain recon. I queue all 30 domains to the resolver's worker's PubSub service, right? But they're queued one at a time. So they're handled one at a time, which means they're resolved and handled one at a time. So each, if you imagine it, let's say it takes 5 minutes to resolve 30,000 domains or something. Great. But one takes like, a second or whatever, right? Like some minimal amount of time. So it runs, it resolves. If it does resolve, great, push it up to the database. If it doesn't resolve, whatever, drop it, do whatever you're going to do, right? But it's one at a time. So now that it's running so fast, It's under, the 10 or 15 minute mark. And these kind of things where you have code that runs pretty constantly or quite often, but it just does one task and it does it quick, makes it a very good contestant, or it has a very good eligibility for a certain type of thing in the cloud, and that's serverless functions. There's Lambda functions in AWS Cloud. Google Cloud has serverless functions. DigitalOcean has serverless functions. They all do. But Google Cloud has serverless functions, and one of those functions is Cloud Run. So you're running containers on a fully managed platform. It's serverless. You only pay for the computing resources and the runtime that you use, and it scales down to 0. So if you don't have, right now I don't have any services running, but we're going to create them in a second. If I don't have any services running, or even if I have services here, but I don't have any workers running at the moment, they all scale to 0. So there's not a container live sitting there waiting. You can have it be that way, but you don't have to. So if there's nothing there for a passive subdomain worker to be doing, it can scale to 0 where it's using $0, which works for me. So, I mean, yes, there may be a point of, as you scale up, something is like things are just running 24/7, and you may want that. And we're going to talk about that at the end and when I say some of my future plans. But for now, I have everything running, and it runs in such nominal chunks. Every worker handles one domain at a time, and all of these tasks can happen so fast. Even passive subdomain recon will happen in under 10 minutes for one domain. Like it's all you're doing is hitting APIs and checking databases and whatnot. Like it just happens. And brute forcing, like what is brute forcing? Like all you're doing is giving it a word list and testing if the domains resolve. So that's basically resolver worker, right? So all my brute forcing worker is doing is creating a brute force, list of domains that I want to brute force. And what then do you have to do? You have to resolve it. So what do? I just send it to the resolver worker one domain at a time. So I'm not sitting there with my brute force worker running for 5 hours while it chunks through millions of possibilities. I just queue it all up and it just happens one at a time. And it just has these services running. Again, when it's done, then it scales back down to 0. And it's great. And it's worked for me so far. Saves a lot of money because I don't have servers running constantly. Runs really quick. Google has, logs and all this kind of stuff for all the services, and you can set up alerting and all that kind of stuff directly in Google Cloud, which isn't Google Cloud specific, but it works. So I really like it so far. It's working for me. And the number one reason why I switched is because, again, when I mentioned in the beginning that I wanted to kind of make it more scalable and a little bit cheaper, which is the cheaper part was the serverless function thing. It works really well. It's very easy to track domains, all that kind of stuff, whatever. But the deployability thing and making it easier for me to manage, well, that's where I started using Terraform. So I'm using Terraform to deploy my whole testing infrastructure, and I modified some stuff so this run, hopefully the demo gods allow me, which we'll see, to run this, but I can deploy it with one Terraform command. And I can deploy, I got my password wrong. That's great. So I can deploy it with one Terraform command, which is really nice. So I had nothing. The only thing I have in Google Cloud right now, I knocked it all back down to nothing, except for I already pushed my Docker containers in there, right? So that's just like you build them locally and push them up to Google Cloud into the GCR. It doesn't have to be from the GCR. You can have them in whatever registry you want. You can have them in, I think, your own registry if you really want to, and try and do it that way. But I just use GCR because it's easier. But that's the only thing that's in Google Cloud right now. I don't have any services even deployed. I don't have anything happening. No PubSub things are happening. None of that. So if I go here and I go to PubSub, you'll see there is nothing here. There's no, they call them topics, right? There's nothing here. So, but I need to deploy it all. So what do I do? Well, very simple. I go here, I go into my infrastructure main, and in here you'll see I have just a bunch of .tf, which is Terraform files. And I have Terraform files for certain things, but as you can tell, there's probably a Terraform file in here for, main, which is probably like the basic service accounts, IAM stuff, whatever, basic stuff, as well as like a Terraform file for each worker. If you want to, you can Terraform plan, which will tell you what it's going to do. right? So if you Terraform plan here, what that basically says, it's like, okay, this is what you would be doing and creating if you did all that kind of stuff. And it's a whole list of stuff. I'm not going to, I already checked this. I'm not going to scroll up because there's stuff in there that I probably shouldn't show. So, but right here is the important part. So it's going to add 20 things, change 0, and destroy 0, right? That's what will happen. So then all I have to do to deploy my whole testing infrastructure, connect it all, everything's all talking to each other, like it's deployed and ready to go, is just do Terraform apply. And it'll do the same thing as the plan, check, and it'll say, do you want to perform these actions? I can say yes, and it will go through, and as you can see, there's a bunch of stuff being created here. So there's service accounts, there's all my Cloud Run services, the Cloud Run APIs, here's the couple of workers that I'm going to deploy, token creators, again, it creates service accounts and all that kind of stuff to bind it all together in the cloud. So in a second here, again, I'm not skipping videos, I'm not doing anything, like there's not going to be a 40-minute skip here of deploy time. You'll see here in a second, like I said, some stuff is already creation completing. It, will take however long it's taking, like 30 seconds to a minute here. And there's 4 workers. And when this is all done and it's all deployed, basically what will happen is I'll have pub sub services for the 4 workers or whatever, the workers themselves, service accounts to connect them all, identities for them all in the cloud, and all that kind of stuff. So it's all done, it all applied, everything's great, hoorah. Now, if I go here and refresh and look at it, you'll see that now I have pub sub stuff. So there's brute force recon, there's 8, like again, this is just an example environment, so it's just kind of up and running. We have sub recon, resolver recon, HTTPX, and brute recon, right? Like permutations was in here and a couple other stuff, right? But now there's pub sub topics here that people can, let's just click into this one for sure. So if you look at it, there's a subscription and stuff is subscribed to it. And again, like you can go check the messages and metrics and details and all that kind of stuff to keep up with it, but that's not really important for the video. Then if you go to services here and we refresh again, you'll see Terraform also spun up all my workers. You can see requests per second, what region they're in. They're in US Central for me. They all require authentication. They're all internal, and they all connect, all that kind of stuff. Great, good, perfect. I can go into subdomain worker here, and you can see request count, stuff like that. Obviously, none of this stuff is working because I haven't sent it anything to do yet. But you can look at all this type of stuff is right. You can create alerting policies for some of this stuff. Again, if you want like an alerting policy when your bill starts going up too high, sure, CPU utilization, container instances, and you can set all that in Terraform. You can set all of your like settings and stuff for these workers all in Terraform. So all I have to do is click Terraform apply and it all goes up. It all connects and everything's great. And I wouldn't try and mess with any of these URLs because again, I'm just going to delete it here by the end of the video. I think I was testing it with Epic Games for a while, maybe back in the day, and the logs will stay. So again, like you can see some of the stuff here, like as it, creates itself and whatever, this publishing a message, this means that it's publishing messages to other, like for instance, the resolver worker, right? So as stuff finishes here, it lets me know that basically this stuff is a success and I can open it up and look at the whole log entry and whatever. But this is basically just telling me that like, yep, it ran in the standard output and stuff like that. If it errors, it will tell me something different, but this, at least for this worker, means that it's working correctly. And again, like just creating and deleting it over and over as I've been working on it. But all these logs, you can have it print anything to those logs. You can say like, I'm doing this and doing this and doing this. And you can have it list all the steps it's doing, whatever. But that's all the workers, right? So all of that gets deployed. I don't have to mess with containers anymore. I don't have to mess with scaling it myself. I don't have to mess with all the different commands and writing little bash scripts to try and deploy stuff and handle it and all that stuff. Is just all Terraform. And the best part now is, let's say like something changes. What I can do is I can re-push a new Docker container to the GCR here. When you go down to container registry here, this GCR, if I go to my subdomain worker here, right now there's just one that's latest. If I redeploy a new container as the subdomain worker to the GCR, this one will drop down to an old version or a tag or whatever, and there will be a new something with the tag latest. And all I have to do in Terraform is configure my Cloud Run service in Google Cloud, these workers here, to say, okay, this subdomain worker should always be running the latest container from this GCR URL. So when I upload a new container with updated code or bug fix or whatever, I don't have to redeploy everything and redeploy containers and boot stuff back up and everything else. It will automatically go to this subdomain worker and it will change all of it. And the containers used from that point on will all go to the newest version of the Docker container. So that works great. And then same thing, if I want to, if I'm just testing stuff right now and I want to save money and I don't want to leave this all deployed and all that kind of stuff, blah, 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 I can go back here and all it is if I can spell it right, holy moly, Terraform destroy, and it'll do the same thing as Terraform apply. It looks through my kind of stuff, everything in the account or everything in this directory. It will look for it in the account and it'll be like, okay, like you want to destroy this? Say yes if you want to, yes, and it destroys it all. So now it's all destroyed once it's done destroying everything. So I don't have to go make sure and like clean up my stuff. The only stuff that's not destroyed is the containers in my GCR, right? Because those were pushed before and those aren't pushed by Terraform. So it says, okay, destroy complete, 20 resources destroyed, great. So now if I go here, I go back to my services, you'll notice they're empty again. Same thing if you go out of the GCR where we were before and PubSub, and I refresh here, gone. So really nice. This is one of the reasons why I upgraded to Google Cloud. It works so nice for me with Terraform. Again, you can do this in AWS. I am not a big fan of AWS in pen testing because it doesn't seem to mix well. I've heard people say that Google Cloud doesn't either. Me personally, I know some of you guys have reached out and been like, oh, Google Cloud may flag or whatever. I've talked to support and read the docs, and they all seem to say that like all is good as long as you're not DDoSing someone or like doing malicious activity. Similar to all the other cloud platforms, and I have not been flagged yet or anything. If I do, then I guess I have to move on. But from what I've talked to from Google support and stuff like that, I've described everything that I'm doing to a T, and no one on Google support has been like, you'll probably get flagged. You're good. Like, no one has given any inklings of that. So I like it right now. The only thing about Google Cloud that I don't like is the data storage costs a lot. So I actually still have my database in DigitalOcean and just send the data there. But that's like the only caveat is there's not really a good free tier for that and stuff. But the other stuff is very cheap. Again, I think for like testing and the running and stuff that I've done this month, or I guess last month, since it's almost the end of February when the time this video is coming out, was like 60 cents. So not bad. Again, plus the cost to run the database in DigitalOcean. But on the Google Cloud side, it was like 60 cents, to like $2, I think, at most for some months since I've been doing this. So very cheap. Again, I haven't been running it full tilt for the whole month and like really like cranking on it because I'm still in development and still working on stuff. But it's really cheap to mess around with a lot of this stuff and build out some really cool stuff for really, really, really cheap is basically what I'm trying to say. So as far as what I'm going to do with the future, there's some thoughts that I have about it. And again, these may change, but I'm just going to throw it out there. So the first thing is at the end of the day, I'd kind of like to make this a true microservice application, which probably shouldn't be running on serverless functions full time and totally depending on it, especially as it scales into infinity. So assuming this actually works, scales really well, and actually ends up finding me some bugs, the end architecture of what I will probably end up with is actually Kubernetes clusters. I will just take a clump of, let's say, like the Recon application. That's just all the Recon workers, and it will clump into a Kubernetes cluster, and I will be able to auto scale Kubernetes clusters, and that's how it will work. The reason why I don't do that right now is because it's really, really, really expensive even to have one Kubernetes cluster. You can have like a little teeny baby Kubernetes cluster on Google Cloud for free. But outside of that, like that's like literally impossible to test with. It's like a little teeny baby. And the second you have any replicas or anything like that, you're getting into the hundreds of dollars right away. But they run way more efficiently. They're way easier to manage. They're way easier to scale, all that kind of stuff. And they actually scale kind of efficiently if you get up into bigger numbers. And there's like there's, discounts and stuff like that. So again, if it was getting into big numbers for me, that's where I would scale it, I would say. But but that will be something in the future. For now, the serverless functions are working really well for me. The reason why they're working really well is, again, serverless functions are normally for like you're doing one thing over and over and over again, and it's just like a quick task and it's done, and you don't need to remember anything from the last run. You don't need to do anything, right? So that's how I architected it. If you didn't architect some of your automation or some of your scripts that way, it doesn't work. Like, you can't take a script that runs for 3 hours and turn it into a serverless function. It doesn't work. So just stuff to consider. This is what I'm doing now. I wanted to get it out there that it changed. If you guys have any questions, let me know. I'd be happy to talk about some of this stuff. And that's really all I got, guys. Thanks. Peace.